Good day, ladies and gentlemen. We continue with exercise 2.7. Now we are under requirement number L and M. It says the information that is given to us below is for question L up to M. So I will be focusing only in these two questions or requirements. The first one say that 1,000 is invested, which is the scenario for these two questions. 1,000 is invested in a fund paying interest at I percentage per annum compounded quarterly. We know that the interest or one of the interest is compounded quarterly, but we don't know how much is the rate for this interest. After n years, the fund stood at 1,231.44. So the fund increased after a certain number of years, which we also don't know those number of years. And after 1.5 years, we are told that the fund stood to a further amount of 1,366 rand 40 cents. So this is what we know. We know that there is 1.5, which is the number of years for the second portion of the investment of this amount of 1,000. And we know that the future value is 1,366.40, which is the future value of the future value, which is the previous present value. Then we know that there was this 1,231.44, which was initially at the beginning was 1,000 rands. But we don't know for how long was it invested for the first period where it became 1,231. Now we are required to compute the value of interest and we are to correct it to 2 decimal places or round it off to 2 decimal places. So let me just draw an underline as I sometimes do. We know that there is this future value at the end of the period, of which the last period was 1.5 years, 1,366 rand 40 cents. That is what we have. And we know along the way that there was 1,000 that was invested, which stood up to 1,231 rand 44 cents. And we know that initially there was an amount of 1,000 that was invested. In this period, n is a question mark, we don't know, and I is also a question mark. In the second period, we know our n is 1.5 years. That means it is a period of 18 months. We know our n and we don't know our I. Then obviously if we don't know our I, we can calculate I in the second instance. Remember once again that we have 1,000 as the present value, which became the future value, and that future value now became the present value for the next 1.5 years. So it was future value, but now it becomes a present value because we are using this amount to accumulate up to 1,366 rand 40 cents. So that is very important to note that a future value can be converted to become a present value of the future amount. If that future value will be accumulating to another future amount, then it becomes the future value. However, the present value of 1,000 rands becomes a present value all the time because it is not the future of the past. It is the present, then it goes forward. So very important to note that we will definitely, or we are likely to be looking for I, our interest rate. And we can say that we are required to compute the value of I and we are to correct it to 2 decimal places. Then after we are to compute the value of n in years and correct 1 to 2 decimal places. So we need to calculate our n, which is for the entire period from the time 1,000 was invested up until the amount became 1,366 rand 40 cents. So let us continue on that same note and we do our calculations. Then I will go to my note for writing. We are under alphabet L. then we know that we have the present value plus minus our present value. It is 1,231 rand 44 cents. 1,231 rand 44 cents. So this is our present value, and this is the present value. And once again, I want to highlight the fact that this is the present value, but it was the future value to that 1,000 rands, but now it is the present value. Now if we are to calculate n, which is from here to here, then we can use we will use 1,231.44 as our future value, then 1,000 will be the present value. But we are not there yet. Remember, we know that our n is 1.5 here, but we don't know our n here. But very likely after we have calculated interest, we'll be calculating our n here, because the interest for this period will be the same as the interest for this period in terms of compounding, because we were not told otherwise. So that means we have to say our future value, it is an amount of 1,366 rand 40 cents. I think I still remember that one. Then our n in this case is 1.5 times by 4. Why am I saying times by 4? I think we were instructed or told that our interest was compounded quarterly, so we need to make sure that our n is the number of quarters. Our n is in number of quarters. So the minute our n is number of quarters, meaning it will be 1.5 times by 4. And if we say 1.5 times by 4, let us use our calculator. 1.5 times by 4, this will give us 6. That means the interest from 1,231 up until 1,666 rand 40 cents was compounded 6 times. N being the number of compound was compounded 6 times. So our n is based on the number of compounds. So this will be 6. If you wanted, you could have said, once again, you could have said 1.5 years is equal to 18 months. Then you divide by the number of months in a quarter. Remember, the number of months in a quarter, there is 3 months in a quarter, because a quarter is made of 3 months in terms of the period of a year, because it's 3, 6, 9, 12. There are 4 quarters in a year. So if you say 12 divided by 4, you get if you say 12 divided by 4, you'll get 3. Or if you say yes, 12 divided by 4, you'll get 3. Then that means there are 3 months in a quarter, by the way. So let us continue on that note. Then after we are to calculate or compute the interest. Remember, our n is the number of quarters. So now after we have said compute our I, we need to multiply by 4 so that we get it as interest per annum compounded quarterly. The per annum, which is compounded quarterly. Then after we do that calculation, don't forget to clear your calculator. Second function alpha 00 plus minus 1,231 rand 44 cents is the present value. 1,366.40 is the future value. 1.5 times by 4 is equal to 6. That means our n is equal to 6. Then we say n. Then we say compute interest. We get once again 1.748363,495. This is interest per quarter once again. So we multiply this by 4 in order for us to get our interest as 6.993453,982, which is equal to 7%. That is 6.99, so that will be 7%. So now this will be 7% per annum compounded quarterly. Compounded quarterly. I want to highlight the fact that is compounded quarterly. Once again, our n was number of quarters. So it was based on the number of quarters. or the number of compounds, meaning there were 6 compounds or 6 quarters, or there are 6 compounds or 6 quarters in 1.5 years. Remember, we're talking of 3 months. It will be 3, 6, 9, 12, 15, 18. There are 3 months in 18 months. So the 7% is per annum compounded quarterly. That means we have calculated the so-called nominal rate of interest. Nominal rate of interest. Remember, if we're calculating the effective, our N will have to be in years. We'll have to leave our N as 1.5 years, just like that. Our N will have to be 1.5 years. Or else you could have said 18 divided by 12. And 18 divided by 12 will give you 1.5. 18 months divided by 12. Remember, 18 months is 1.5 years, 1.5. 18 divided by 12 is 1.5. So if we had left our N as 1.5, which is in years, the I that we're going to get, it was going to be interest per annum, which is the effective rate of interest. That is for the whole year. But now we're calculating the nominal rate of interest, which is the one that is compounded per compounding period, of which in this case is per quarter. So we have to multiply by the number of quarters in a year, because our N was the number of quarterly compounds in a period of 18 months. So I think I'm making myself very clear, because I'm also clarifying some of the things that I said before with regards to the compounding and the calculation of the effective or the nominal rate of interest. So we can agree that this is the nominal rate of interest, because our N is the number of quarters and our I was per quarter, and we said how many quarters do we have in a year? There are 4 quarters. We multiply by the number of quarters, then we go to the interest per annum compounded quarterly. So we have responded to the first requirement, which is number L. Then now we are to respond to the second requirement, which is alphabet M. Now M, obviously we are looking for the unknown, which is N. We are to compute the value of N, correct it to 1 decimal place. Remember, we know our N here is 1.5, so this is the N that we are looking for. When 1,000 was invested and became 1,231, it stood to 1,231. Then we have our alphabet M. Then we say plus minus 1,200 plus minus 1,000 plus minus 1,000 is the present value, the amount that was invested. Remember, when you invest money, cash goes out of your account. So hence I'm using the plus minus. The calculator will acknowledge that as a minus. Then we have the future value. Our future value is 1,231.44 cents. Then our interest, in this case, we have our interest as 7 over 4. Now, when I'm saying 7 over 4, I want you to take note of this. When I'm saying 7 over 4, remember, my interest is 7% per annum compounded quarterly. So this is per annum. But we know that per quarter is how much? This is per quarter. This is per quarter. So when I'm saying divide by 7, divide by 4, I'm saying the interest divide by 4. It will give me the interest per quarter. That means my I is per quarter. So the answer that I will get will be the number of quarters. Take note of that. The answer that I will get will be the number of quarters. It will not be in years. It will be the number of quarters. Then from the number of quarters, then I need to calculate the number of years. Now, let us compute our N. Compute N. Then now our N, after we have calculated, we need to divide it by 4. Why? Because there are 4 quarters in a year. Now let us do our calculation, then I will again do this further explanation. Very important, this question to highlight. Plus minus 1,000 is our present value. 1,231.44 is our future value. 7 divided by 4 is our I. And remember, this will give us 1.74. Therefore, now that I is per quarter. And the answer that we'll be getting, compute N. The answer that we'll get will be 12.000 4 zeros, I can say this is just 12. 3207. Quarters. This is quarters. So now we need to say we have how many quarters? We have 12 quarters, but we need to know now how many years are those. So now we need to divide this by the number of quarters in a year, which is 4. Then if we say this divide by 4, it will give us 3.00, which is 3 years. So now we can agree that our n is 3 years. Now, in other words, we are saying 12 quarters is equal to 3 years. Let me repeat that. 12 quarters. Why am I saying this is 12 quarters? Because my I was per quarter. 1.748336. There is the same. That is per quarter. That was my I per quarter. And I multiplied it by 4 quarters and it gave me for the whole year compounded quarterly. So now when this is per quarter, then the answer that I'll get will be n as number of quarters. So the 12 is the number of quarters, meaning we have 12 quarters. Let us simplify the 12 quarters for more clarity. Now we know that a quarter is made of 3 months. So if you say 3 times by 12, if we say 3 times by 12, we should be getting 36. 3 times by 12 is 36. Now remember, I'm saying this is 12 quarters, and a quarter is made of 3 months. So if you say 3 times by 12, we get 36 months. 36 months. So in other words, 12 quarters is equal to 36 months, and 36 months is equal to 3 years. So when I'm saying I have 12 quarters, in other words, I'm meaning that I have 36 months, and 36 months, if I divide by the number of months in a quarter, which is 3, then 36 divided by 3 will give me 3 years. 36 divided by 12. 36 divided by 12 will give me exactly 3 years. 36 divided by 12 will give me 3 years. Now I'm converting the month into years. You divide by 12 when you're converting month into years. So that will be 36 divided by 12 will give me 3 years, of which 3 years is equal to 12 quarters. 12 quarters is equal to 36 months, and 36 months is equal to 3 years. So please guys, master what I'm explaining here. It is very crucial explanation to take note of. With that, I think I've dwelled and explained enough with regards to question number M. And with those words, guys, let me leave you with a lovely closing. God be with you. You've been wonderful listeners and responding to the question. Please, as you're listening to the video, make sure that you are doing the question so that you practice while you are listening. With that, thank you very much once again.